Laminar flow is one of the coolest properties shown by water or such kind of liquid. It's almost freezing, but it's flowing actually. And to start this, we will fill the balloon full of water. Let's do this. It takes some time, but hold on. And to prevent any kind of interruption during laminar flow, we will remove the extra air inside the balloon. Yes, this is totally air free now, and we will just tie this now. Yes, this is completely ready now, and see how it actually looks like after filling full of water. Let's do this. And now we will be using an electrical tape to make a little square on the surface of the balloon. You just can see that a small square on the surface of the balloon is made, and we'll make a small hole at this center point of the balloon. It's almost ready for the experiment. Now I will puncture the balloon. Laminar flow is one of the coolest properties shown by water or such kind of liquid. It's almost freezing, but it's flowing actually. But it's super steady if you see closely. This is super steady. See. Let's consider these are the cross-section area of two hollow liquid carrying tubes. In the first case, you can see that the flow paths or the streamlines of the liquid are parallel to each other, and in the second one, they are crossing each other, making them turbulent in nature. So you can say that the first one is laminar flow and the second one is turbulent flow. A force F is required to maintain constant velocity V. You can see that the flow paths are considered as layers stacked upon each other. Greater the friction between two layers, greater the probability of non-laminar flow. If the layers are maintaining proper constant velocity to each other, lesser the shear force, lesser the friction, higher the probability of laminar flow. So what are the prerequisites to get a proper laminar flow? First of all, lesser the viscosity of the liquid, lesser the friction between the layers of the liquid, and lesser the velocity of the liquid flowing through the tubes. And the Reynolds number must be less than 2000. This is how a proper laminar flow is achieved. And now, laminar flow is one of the
very capable, but purely in terms of boundaries, we can